Okay, well, this is what I was going to talk to you tonight about, and how we could transform the Mountain landfill into a community gem. And in a past life, I was a hydrologist and manager at Arizona Department of Environmental Quality, really based out of Phoenix. And I was born here, occasionally made trips down to Tucson, including investigating at least a couple landfills down here. And during my career, I investigated and managed people who investigated probably over a dozen landfills, the purpose of which was to try to determine whether those landfills were in severe enough environmental condition that we had to do future remediation on it. And so there are a number of those around the state that there's remediation going on. One landfill that I personally investigated was the Hassayampa landfill west of Phoenix in Maricopa County, which went on the federal, and the documentation that we got from that investigation went on the federal Superfund list more than 30 years ago. It is still on the federal Superfund list and still being remediated there. But the questions I wanted to cover tonight are these. So, does the Mountain landfill pose a danger due to generation and migration of hazardous gases? The first question. Second question is, does the Mountain landfill pose a danger as a groundwater pollution source? And the third question is the Mountain landfill safe for compatible open space use? So, okay, sorry. So I'm going to be drawing from a number of reports here. The two probably most thorough reports, one was done by the city of Tucson in 2011, and then one done by an environmental consultant actually based out of Tucson, Hydrogeochem, in 2015. In addition, some of the more recent water quality work was done by the city of Tucson in relationship to their Heritage Recharge project. They submitted a big report to ADQ as part of their permit that has a lot of information. And then we'll touch on, I think we're going to be touching on a little later, on a letter that Hydrogeochem put out in just April of this year. So just a little background on the landfills here. So in Tucson's Birthplace, there's a whole string of landfills along the Santa Cruz River, probably maybe 15 of them. In that 2011 report that I talked about that Tucson did, the city of Tucson evaluated all those landfills. 3 of those landfills are in the area of Tucson's Birthplace, and they originated as clay excavation pits in actually from before the turn of the last century to 1963 for brick making. And those pits ended up being turned into landfills. 3 of them, the Nearmont landfill up near Cushing Street now, the Congress Street landfill, which is kind of took a lot of the area just south of the current Caterpillar building. The Mountain landfill kind of sits where it has been for years. And it looks like the PowerPoint is mixed up a few things, but the first environmental investigation of the Mountain landfill was way back in 1983. And they've been doing long-term monitoring at that landfill for at least 20 years. So in 2000, there was a survey done to determine the depths of trash or refuse in the Mountain landfill. This is the map from one of the reports here. And it turns out, you can see where Mission Garden is there. It turns out that the deepest pits in the landfill are up in that northwest corner there, maybe 30 to 45 feet deep. And the landfill pits shallowed out in depth, going west toward Granby Avenue. So we want to talk about landfill gas. There are two main things that we're concerned about here. One is the generation of gas from landfills, and the other is the groundwater. So we're going to talk about the landfill gas generation first. And they generate gas because the decomposition of the organic garbage that makes methane. And methane can move out, migrate out through the soil, and it can accumulate in closed structures and cause fire and explosion hazards. There also can be excess carbon dioxide in the landfill, and that would be, the methane would be through the anaerobic decomposition. The carbon dioxide would be through the aerobic decomposition of garbage, and also the aerobic transformation of methane. So it would be two sources of that. And the excess carbon dioxide could, if there's a lot of it, could limit vegetation growth on the landfill surface. So it's not like these landfills haven't been, including the A-Mountain, haven't been monitored. They have been just intensely monitored for the landfill gases since 2000, both interior, those are a list of all the sampling ports, interior, and then exterior to detect any off-site migration of landfill gases. Okay, there. So right now, the city of Tucson monitors two off-site migration wells right up between Mission Lane and the residents north of Mission Lane, here and here, and then one down here at the south end of the landfill, quarterly for landfill gases. And since they began sampling in 2000, they have never detected methane gas, off-site movement of methane gas into those off-site wells. There is methane being generated in some of these within the landfill. So the conclusions from these reports are that in 2015, Hydrogeochem said methane generation rates at the site are relatively low. In 2024, that letter that I mentioned, they say there doesn't appear to be any lateral migration of methane. And I think the word is about carbon dioxide limiting vegetation growth really haven't come into play here. So let's talk about groundwater now. Here's a diagram of the landfill again, a mountain landfill. City of Tucson maintains 5 wells monitoring those 3 landfills. Of course, 2 of them now are filled with clean fill in the area of Tucson's Birthplace. 4 of those monitor wells are actually constructed for the purpose of monitoring. One at the south end that is actually the compliance well for Tucson Water's Heritage Recharge Project for meeting water quality standards there. There's a monitor well within the southeast corner of Mission Garden, an old production well that they're using for monitoring kind of the northeast corner of the landfill, and then 2 others that are just north of Cushing Street there. And so they monitor those. Right now, they monitor the water levels. They take water level measurements weekly from those wells. They're at Mission Garden every Thursday morning, taking the water level on the wells at Mission Garden. And because of, which we'll talk about in a moment, the rise of water level in that area due to recharge, they're actually taking groundwater samples for analysis quarterly, and in some cases even more frequently than quarterly. Groundwater flow direction underneath the site is generally in the direction of those arrows, which got offset somehow in this, but kind of south to north underneath the landfill. So what do we know about these? Well, before the recharge project started, the depth to groundwater below the land surface there was about 120 feet before 2022. The water levels that they're measuring in these wells now around the landfill are between 30 and 35 feet below land surface. And I talked to the Tucson water person, I think 2 weeks ago, and they measured 34.4 feet below land surface. So what that means is, since 2022, that water table has risen into the bottom pits of the landfill. And that has, of course, concerning Tucson water, which is the reason they're doing this enhanced groundwater sampling to see whether it's causing any problems. But they have been routinely sampling those wells since 2000, and they've never had a detection of any constituent, any pollutant that exceeded regulatory limits in any of those monitor wells. And in fact, you could pump all those wells if you wanted and serve them for drinking water if you want, because all the samples of that federal drinking water and that ADEQ aquifer water quality standards.
Okay.
In one monitor well, though, there have been some detections of an organic chemical. This happens to be a monitor well on the Mission Garden site, of a compound called cis-1,2-dichloroethylene, which is actually a degradation product of another compound that was probably maybe disposed of in a very small amount because the levels are so low. But you can see here that this is the historic range of concentration or the amount of that contaminant that's in groundwater, which is very, very low. And so just trace levels. The current drinking water limit is up there, 70 micrograms per liter, which actually sounds like a lot, but it's a very, very tiny amount. So that level is set to protect public health. So even with these detections, there has never been any really concern with respect to the federal safe drinking water standards. And interestingly, since the water level has started rising into the pits, the levels of those have actually even decreased to the lower side of that little yellow band there. So the conclusions with respect to groundwater quality from the 2015 Hydrogeochem report are no substantive impacts to groundwater appear to be associated with the amount of landfill under current conditions. In 2024, they say there doesn't appear to be any significant impact to groundwater based on City of Tucson monitoring. And then the last conclusion there is based on kind of my reading of the City of Tucson's report to ADEQ, that the recent rise of groundwater into the deeper pits of the landfill has had no discernible adverse effect on groundwater quality. So, can this landfill be used for future uses? And these are some statements from the Hydrogeochem's letter on April 2024. There doesn't appear to be any significant impact to groundwater based on the City of Tucson monitoring nor lateral migration of methane from the A Mountain landfill. The biggest concerns with respect to building, if you were to build on the landfill, are that methane concentrations would likely increase in soil and could potentially cause an explosion hazard. Then they also talk about a possible stability issue, whereas this refuse is decomposing. You might get some subsidence if you put a structure on the landfill. And then their earlier caution about carbon dioxide, again, has proven not really to be an issue. So Hydrogeochem says that the landfill could be successfully planted and used in open park space. And if you use closed structures, they're saying open structures on the landfill would be an issue where methane could potentially accumulate. It would be best to limit those to the thinner refuse and avoid those deeper pits up in the northeast part of the landfill. So what could you do with the landfill then? And these are just some possible things that could go on the landfill. I'm not advocating particularly any of them, but with native trees and other vegetation, of course, it would create an open space. It's actually a de facto open space for wildlife now. Walking and bicycle path, picnic tables, Vermontis River overlooks some children's activity and educational areas, and could have interpretive displays and other learning features. So, getting back to our questions here, does the A Mountain landfill pose a danger due to generation and migration of hazardous gases? I think the check mark's in the no. Does it pose a danger as a groundwater pollution source? I would say 30 years of monitoring says no. And is the A Mountain landfill safe for compatible urban space use? And so I think that's a yes. So anyway, that's the situation. I didn't touch on the real technical aspects, and when we break out into groups, I have some boards back there that go into kind of the technical issues related to these conclusions.
Yeah, keep that going for Chuck one time. What an amazing advocate to have as part of our coalition. Retired hydrologist, used to work on landfills for ADEQ. I mean, you can't ask for something more expertise than that. So thank you so much, Chuck, for breaking that down for us.